Okay, we are going to find the linear regression and answer those questions right there for this set of data: law school candidates, prep times, and test scores. First thing we want to do is go ahead and get this data into an Excel spreadsheet or a Google spreadsheet. Once that's in there, we have several questions to answer. Those questions are going to be not done in order. In order for me to create a scatter plot, it might be good to use desmos to see what it looks like, but you'll do that on paper. We want to discuss the correlation. We need to see the scatter plot. In order to find the sum of least squares, I need the best fit line first. These two are the same, just using different terms. And lastly, we want to interpret the data. So let's start with our data in Excel. If I were to simply just copy and paste this data into Desmos right here, it'll automatically plot the data for us. That's kind of nice. From there, the line of best fit we can find simply by plugging in equals and start typing in line regression, but it isn't line regression. It comes up as line estimate. We want that one. It's asking us to put the y values in first, comma, x values, enter. And notice that it gave me my slope, and y-intercept. Okay, that gives me an equation that says y equals 2.45, y equals 2.456, x plus 3.298. That's my line of best fit. Now I'm going to use that in this column right here to find the estimated values of the line. Okay, and I'm going to plug that in as equals 2.456 times, so that's shift 8 or asterisk, and it's going to be A1, that value in A1, plus the y-intercept 3.298, and we hit enter, and we've got our y value from the estimate, from the best fit line. I can drag that down, I get all of them. Again, y values from best fit line. Okay, now we want to find the residuals, and that's simply by going equals this y value minus this y value, drag down, and I have them all. Next is the squares, equals this value squared, so shift 6, 2 gives me that value squared. Copy down, and now if we find the sum here, sum of all these numbers, and I got 15.12. Now again, that's the least possible value from the residuals. It doesn't get any smaller than that. So let's go ahead and graph our line. Now if we go over to Desmos there's an easy way to do this, and you just simply plug in y1, and the 1 comes from the fact that you've got, it's labeled y1 in the plot, and you're going to use a tilde, shift tilde, um, m for slope, x1 plus b, and it actually graphs the best fit line for you automatically. Notice that those numbers down here, slope and y-intercept, are those same numbers that we had on the spreadsheet. Okay. We could also plug in the numbers that we had from the spreadsheet. Remember, it was y equals 2.456 x plus 3.298 was what we plugged in. Let's give that a nice pretty color. Okay. And notice that those end up being the same line, don't they? So there's my graph. Now you can do that on paper. You can see how it looks here. It's pretty cool. The other thing that you ought to do is go ahead and hit that plot. When you do that, notice that you get an E sub 1 value. Those are your residuals. Those are the same values that you have in this column right here. Those are plotted down below in blue down here. It's pretty cool. You can see how the distance they are from the x-axis. So we're now at a point where we've created a scatter plot. The correlation, if you look at the graph, seems to be a positive correlation, and it looks to be fairly strong. We've discussed the R values before too. You can see the R value is 0.976. That tells you how strong it is. It's good, strong correlation. The sum of least squares now, if we go back to the spreadsheet, that was this value right here, 15.1228. The equation of least squares, we did that twice. We saw that both on the spreadsheet here and also on Desmos down here from from what we wrote in and from M and B given to us. The last thing we got to do, graph it. We did graph it on Desmos. You're supposed to graph it on paper. Interpret the data. Well, if we look at this, how would we interpret this? Remember, this data is number of days studied on the x-axis and the scores earned. And it appears that the longer we study, the number of days we studied, the better the test score is going to be.